In today's video, we will be solving in-text questions of Chapter 2 Acids, Bases and Salts from NCERT CBSE Science Textbook Class 10. Page number 18, first question says, you have been provided with 3 test tubes, one of them contains distilled water and the other 2 contain an acidic solution and a basic solution respectively. If you are given only red litmus paper, how will you identify the contents of each test tube? So we have to start here with dipping the red litmus paper into each test tube one by one. If the red litmus turns blue, we know that the solution is basic. Here we can eliminate one test tube that is basic. Now we have 2 test tubes in which there is no change, so they can be either acidic or neutral. What we do next is we take a small amount of basic solution that we know is basic and mix it with each of the other 2 solutions one by one in small quantity. Now when the acidic solution is mixed with base, the mixture becomes neutral and your litmus paper won't change color. However, when the neutral water is mixed with the base, the red litmus is going to turn blue as it remains basic. So from here we can see which one is neutral and the leftover one will be acidic. In page number 22, first question says, why should curd sour substances not be kept in brass or copper vessels? We know that curd has lactic acid and sour substances such as lemon also contain acids. Now, if these acids are kept in metals such as brass and copper, they're going to react and form toxic salts, because we know that the reaction between acid and metal forms salts and some of these salts can be toxic, which can be harmful for consumption. So that's the reason we cannot keep curd in brass or copper vessels. Second question asks, which gas is usually liberated when an acid reacts with a metal? Illustrate with an example. How will you test for the presence of this particular gas? So we know that an acid and metal gives us salt and hydrogen gas. And how to test for this? We can take an example of zinc and hydrochloric acid, which gives us zinc chloride and hydrogen gas. And in order to test for this, we can conduct an experiment where we can react zinc with hydrochloric acid and we can bring a burning splint near the gas, and this gas will be put off with a pop sound which indicates the presence of the hydrogen gas. Third question asks, metal compound A reacts with dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. So we are said that there is a metal compound that is reacting with HCl and it is giving out effervescence. Effervescence is nothing but bubbling or fizzing. That means a gas is being released. And now this gas that is extinguishing the candle, it should be carbon dioxide, because we know that's the common fire extinguisher. And one of the products is calcium chloride. So we know that the metal ion is nothing but calcium ion. We know that metal carbonates release carbon dioxide when reacting with acids. Now I know that the metal ion is calcium, so the metal compound has to be calcium carbonate. Let's write the equation for this. Calcium carbonate reacts with hydrochloric acid to give calcium chloride, carbon dioxide as well as water. In page number 25, the first question is, why do HCl or HNO3, that is hydrochloric acid or nitric acid, show acidic characters in aqueous solutions, but solutions of compounds like alcohol and glucose do not show acidic character? So the main reason that these show acidic character is the requirement for acidic character, which is release of H plus ions. So HCl, HNO3, these kind of compounds, they release H plus ions in water, or more accurately hydronium ions, which shows the acidic nature. On the other hand, alcohol and glucose do have hydrogen atoms, but they do not ionize. Now why don't they ionize? The reason is glucose and alcohol have covalent bonds, not ionic bonds. The hydrogen atoms in them are tightly bonded to carbon or oxygen, because of which they do not ionize in the presence of water. They may dissolve in water, but they do not ionize, which is the requirement for acidic nature. Why does an aqueous solution of an acid conduct electricity? So let's look at aqueous solution of hydrochloric acid. We know that when HCl is added to water, it dissociates into H plus and Cl minus. Now these free ions move freely in the solution and electric current passes through the movement of these charged particles. That's the reason they conduct electricity. Why does dry HCl gas not change the color of a dry litmus paper? We know that hydrochloric acid is an acid and it has to change the dry litmus paper, but this dry gas do not change the dry litmus paper because we need this to dissolve in water to release these H plus ions, which gives it this acidic properties. Dry litmus paper does not have moisture, so HCl gas does not ionize, so no H plus ions, so no change in the color of the litmus paper. While diluting an acid, why is it recommended that acid should be added to water and not water to acid? This is because diluting an acid is a highly exothermic reaction. It releases a lot of heat, and when this heat is released, the water sits on the top and heats up quickly, sometimes boiling instantly. Now this boiling can cause acid to splash out, which can burn skin, clothes or eyes. That is why it is recommended that acid should be added to water and not water to the acid. How is concentration of hydronium ions affected when a solution of acid is diluted? So when you dilute an acid, we are adding more water to it. This reduces the number of hydronium ions per unit volume. Now this solution becomes less acidic, that is, the pH increases. What happens to OH minus concentration when excess base is added to the sodium hydroxide solution? So sodium hydroxide we know is a strong base. That means it fully dissociates in water to give Na plus and OH minus. Now on adding more base, the concentration of these hydroxide ions, that is the OH minus ions, increases. Now when this happens, the solution becomes more basic. So the pH of the solution becomes closer to 14, that it becomes blue to purple. In page number 28, the first question asks, you have two solutions A and B. The pH of the solution A is 6 and the pH of the solution B is 8. Which solution has higher hydrogen ion concentration? Which of this is acidic and which one is basic? When pH is less than 7, it is acidic. When pH is more than 7, it is basic. So, solution A has to be acidic and solution B has to be basic. What effect does the concentration of H plus ions have on the nature of the solution? So, higher concentration of H plus ions, more acidic nature, lower concentration of H plus ions, less acidic or basic nature the solution becomes. Do basic solutions have H plus ions? If yes, then why are they basic? Yes, basic solutions also have H plus ions. However, the concentration of OH minus ions is greater than these H plus ions. So, even though they are present, they are fewer than the OH minus ions. Under what soil condition do you think a farmer should treat the soil of his fields with quicklime, that is calcium oxide, or slake lime, that is calcium hydroxide, or chalk, that is calcium carbonate? So, all these three compounds that are mentioned here are basic in nature. So when added to acidic soil, they'll neutralize the soil. So this have to be added to acidic soil in order to restore the soil's pH to neutral to grow healthy crops.